steady process. So what it means is, during a steady flow conditions, total mass inside the control volume and total energy inside the control volume will remain constant, will not change. This is a characteristic of a steady flow process. The mass is constant means that does not mean mass is entering. Mass is entering and mass is leaving. The rate of entry, rate of leaving is equal. Rate of energy entering the system, rate of energy leaving the system is equal. Only then mass and energy of the system will be constant. Control volume will be constant. Okay, otherwise it will not be. There's a flow. Energy is flowing. Energy is entering. Energy is leaving. Mass is entering. Mass is leaving. But the rate of mass entering and the rate of mass energy entering is equal to rate of mass leaving and the rate of energy leaving the system. Under such conditions, the net content, what remains in the system, is constant. What is there in the control volume is constant. So just to give you a crude analogy, it's not very exactly the crude analogy of things. Let's say you take a college. Number of students in the college, let us assume. What is that? Some number, right? Final year students, third year students, second year students, and first year students, right? Is constant. It's almost constant. Right? It will not change much. Right? That doesn't mean students every year, fresh students take admission and the final year students graduate and they leave. The number of students entering the college, number of students leaving the college is equal. If it is equal, then amount of students that come to college every day will be constant. It will not change. Right? If there's a mismatch between number of students graduating and the fresh students taking admission, if there is a mismatch, is not equal, then either number of students on the campus will increase or decrease depending on the condition. Okay, so that is not a steady. Steady is something where exit and entry are equal, right? So when exit and entry are equal, rates are equal, then net content within the system will be constant with respect to time. It will not change with respect to time. So this is given by picture pictorially. It is depicted here. If you take control volume for a steady flow system, the mass of the control volume is constant. Energy of the control volume is constant. This is the characteristic of a steady flow process. If mass and energy are not constant, then such process is not a steady flow process. Okay. Another way of saying whether the process is steady flow or not, how can you find out? If you find that mass and the energy both are varying with time, then you can conclude that it is not a steady flow process. Zeroth law of thermodynamics. So you must be wondering why zeroth law, right? So there are laws of thermodynamics. I think you have heard already. First law, second law, that law. So people invented these laws are laws of nature. Okay. Law means what? Law means law you cannot violate. Right? There is some law. Government makes some law. Law means you cannot violate. No arguments. You have to follow this. That's all. If you are going on road, you should go left side, right? On the road, always wear helmet. This is the law. You have to follow it. If you don't follow, then you will be penalized. Police will come and penalize. Similarly, nature also, you cannot violate the law, right? You can't violate the law here. So natural laws cannot be violated. All natural systems have to follow the natural laws of the nature. So if you see this first law and second law, their existence was understood or realized by human beings maybe after the invention of engines. Okay. Once the engines were invented, only then people realized that there is something called a first law and a second law for thermodynamics, because people were working on engines. Right? Engine is basically overproducing. It produces work. Right? So work is a form of energy. That we'll see later. Work is known as a form of energy. So if you see here, this work, naturally when people were developing engines, when they were first invented, James Watt, when he invented the steam engine, there was natural tendency, right? I want to get more work, right? That's what we want. We want more from whatever we invest. So you are burning fuel, coal you are burning. If I can get for 1 kg of coal, whatever amount of work I am getting today, if I can make it more, I'll be happy, right? So there was always a tendency to increase the efficiency of the engine or increase the power output of the engine. But people, when they were working on this, they found that they were hitting some limit. Beyond certain limit, they cannot increase the energy anymore. There was some natural limit was there. Whatever you do, you improve the system, whatever improvement you, engineering improvement, scientific improvement you bring, they were realizing that you cannot increase it beyond point. Certain point you cannot get. You cannot. Your yield flattens, doesn't increase much. So why it is? How it is? So people, those time, very brilliant brains gave considerable amount of thinking, and they said that there are laws of nature. First law of thermodynamics you cannot violate. Second law of thermodynamics you cannot violate. So they first found out the first and second law. Then they realized there is another law of nature. It is called zeroth. So, but logically we should have found out that this zeroth law first, then first law, second law. But it did not happen. The scientists, they invented first the first law, second law. They discovered, not invented. They discovered first law, second law. Then they discovered the zeroth law. So therefore, it should have been logically zeroth law should have been first discovered, but it did not happen anyway. So they thought this should have preceded the first and second law. Therefore, they gave the number zeroth law. That is how it got the name zeroth law of thermodynamics. So what it says, what is the zeroth law of thermodynamics? If bodies, let's say two bodies are there. Body means which has mass, right? So there is a body A which has got some mass MA, another body mass MB, each in thermal equilibrium, right? I say two bodies are in thermal equilibrium, right? Two bodies in thermal equilibrium. What is the meaning of thermal equilibrium? We have already defined thermal equilibrium or thermodynamic equilibrium. So thermal equilibrium means no temperature difference, right? Correct? There is no temperature difference. Thermal equilibrium, mechanical equilibrium, and chemical equilibrium. We have discussed already. Right? So when all three are satisfied, we call it as thermodynamic equilibrium. Thermal equilibrium means no temperature difference. Temperature is same. A and B are at a same temperature, right? With a third body at a T. I have body A, body B, and there is one more body called T. I call it as T. Then A and B are in thermal equilibrium with each other, right? If body A is in thermal equilibrium with body B, okay? So here I find that A, I bring in contact with the body T, body A, body T are brought in contact. So I find that there is no change. The thermal state of T and A don't change. Right? There is no heat transfer. Right? So there is no change in properties of A and T. Suppose if they were at a different thermal level, then there will be some change. Right? Energy will flow from here to here to either way. Either way it will flow. We find that there is no energy flow. Right? So it is equilibrium. Similarly, I find that the same body T is also in equilibrium with the body B. Right? So I separately bring them in contact. First I bring it in contact with A, then I bring it in contact with B. So both the cases I find that T is in equilibrium with A and B. T in equilibrium with A separately and also in equilibrium with B separately. Right? So if that is the case, I can conclude that A and B are also in thermal equilibrium. So thermal equilibrium means there is no flow of heat. Right? Thermal equilibrium means if there is no thermal equilibrium, then heat will flow. Right? So if you touch something that is the same temperature that of your body temperature, then you don't feel anything. If you touch anything that is colder than your body temperature, then you feel cold. Why you feel cold? Why you feel cold? Because heat flows from your body to the cold body. Then the temperature of the skin decreases. Therefore, you feel cold. Right? Similarly, if you touch hot body, heat will flow from hot body to your hand. Therefore, you feel hot. Right? So there won't be any heat flow if the both are at the same thermal level, same temperature level. Okay? So or thermal state. So if two bodies are at the same thermal state, then they don't exchange heat. Okay? If two bodies don't exchange heat, that means the two bodies are at thermal equilibrium. You understand? Vice versa. If two bodies are in equilibrium, they don't exchange heat. If two bodies are not exchanging heat, means they are in a thermal equilibrium. Either both ways. Okay. So this law defines this gave the definition of a temperature. See, initially this concept of temperature was not there. Right, olden days people did not know, the temperature was not known. Temperature of the concept of temperature came into picture only when this law was invented. Okay? So initially either people only reference was used, either something is hot or something is cold. We never had some property, we did not define a property called temperature, then you can have a temperature scale like this. It was not there earlier. So from Zeroth law the concept of temperature came into picture, which said that every body is at some thermal level. So that level is defined by some property called temperature. If these thermal levels are equal, then two bodies are at the same temperature. If two bodies are at the same temperature, means they are at the same thermal level. If two bodies are at the same temperature and thermal level, that means they don't exchange heat. If two bodies are at a different thermal level, means they are at a different temperature. That means when two bodies at different temperature are brought in contact, they exchange heat, right? So when the heat transfer happens, when two bodies are at two different thermal levels. So this is how the concept of a temperature came into picture. So this Zeroth law defines is a definition of the temperature. Temperature and the Zeroth law. By replacing third body, suppose third body is there, if I replace it by some thermometer, the Zeroth law can be restated as two bodies are in thermal equilibrium if both have same temperature reading, even if they are not in contact, right? So if even if they are not in contact. What is temperature? Temperature is associated with the ability to distinguish hot from cold. What is temperature? Temperature is something that distinguishes hot from cold, right? So like wealth, money. Money distinguishes, what it distinguishes? Rich and poor. Someone has got more money is called a rich. Someone who has got a less money is called a poor, right? Wealth is measured by money, amount of money you have. There are other methods of measuring the wealth. Okay, so one is temperature. Okay, so the one is money. So here temperature also measures wealth or a richness or a poorness of the. Similarly, the temperature measures here hotness or coldness of a body. Whether a body is hot or cold, how you measure it is by measuring the temperature. When two bodies at a different temperature are brought in contact, after some time, equilibrium is established between. If you bring the two bodies at different temperature, what will happen? They will exchange heat. When they exchange heat, what happens? Hot body loses its heat, thereby its temperature decreases or its thermal level decreases. Cold body gains heat, or its temperature increases, thermal level increases, or temperature increases. So that means one loses, one gains, and at the end both will become equal. Right? So this is how in nature things play out. So two bodies reaching thermal equilibrium after being brought into contact in a isolated enclosure. This is very important. Okay, two bodies in a contact in an isolated enclosure. They must be isolated from rest. Suppose I have an iron piece, I have brought it in contact with copper piece, but here I am not isolated. I keep on adding heat, right? The iron rod, other end I keep on heating. Then this will not become, its temperature will not decrease. It will remain steady because it is continuously getting energy, right? So this is very important. Two bodies brought in contact which are isolated from rest of the universe. Isolated means no energy transfer, no mass transfer, right? When they are isolated, both are isolated from rest of the world, but they are in contact. They are in contact. So when they are in contact, what will happen? They will attain a thermal equilibrium. That means temperature after some time will become equal. Let's say 60 degrees. This was at 150 degrees. This is at 250 degrees initially. After some time lapse, both pieces have become 60 degrees Celsius. Right? Thermometer. What is thermometer? Definition of the thermometer. Okay, this definition of thermometer and a lot of things are there. We need to discuss. Those things we'll discuss in the next class. Time being, now you please go back and read once again whatever I have been every day and introducing new terms. So these terms you should be very, very thorough about. Okay. So I'll keep that topic open for discussion for some time. Then we'll close this session. So if you have any doubt, you can ask question. Okay. Now topic is open for discussion. If you have got any doubt, please don't leave the meeting. I will download the attendance. Then you can leave the meeting. So can you hear me? Are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Sir.
So how was it? Okay, can you hear me?
Yes, sir.
Yes, sir.
Any doubts? Any
Yes,
questions?
sir.
No questions?
No, sir.
You understood everything? Huh? Whatever I taught you understood, eh? Yes or no? Rena? So that means we'll have test next week, right? You understood everything? Are you listening to me or not? Hello? Are you there?
Yes, sir.
Yeah. Can you hear me?
Yes, sir.
Okay. Did you understand everything what I discussed? System, process, equilibrium, steady flow process, Zeroth Law. You understood everything? Okay,
Sir,
fine.
when will you give notes, sir?
I'll give. You need notes, I'll send. Okay. You just remind me in a day or two, I'll send it. Okay. Every day you should ask me. I'll forget. So, okay, keep reminding me. I'll send the notes. Okay. So one of you share your. Who is your class here?
Not selected.
Not selected. Okay, no problem. We have a Moodle. You are accessing Moodle, right? I'll upload in Moodle. You can download from the Moodle, right? I'll do that.
Sir, you can share even here, sir.
Here the notes cannot be shared, no? I'll share
Can,
here.
sir.
Okay. I can share. I'll share. I don't know. This is the first time I'm using this. I don't know how to share. Let me see. I'll do that. I'll share it here.
Sir, you shared, sir.
Sorry?
WhatsApp group you shared, sir.
WhatsApp
No,
group.
fine. WhatsApp, let me see. Okay. That college is saying you should not share in WhatsApp. So I'll share in this platform only. You download it from here. Okay. Okay. If it doesn't work, then I'll share in WhatsApp. No problem. Okay. If it works,
Thank you.
Yes, sir.
First I'll share here. Let's follow the protocol. If it doesn't work, then I'll share in the WhatsApp. Okay. Is that fine?
Sir. Yes, sir.
Okay. Then we'll stop class session here. Right? Shall we stop?
Yes, sir.
Okay. Bye.
Yes.
Bye, guys.